Hi there. This is version B of Unit 5 test, and please note that you need to make sure that your answer choices are the same ones that are on this test. So when I'm going through it, don't take for granted that A is A. So make sure you're reading what the answer is actually. For number 1, it says describe how to rotate a 2D figure in order to create a hemisphere, a half a sphere. So if you notice, a half a sphere has rounded on one side and it is flat on the other, or the semicircle does. So, and that's how I want my hemisphere to be. I want it to have a flat surface here. So to do that, it's going to have to be rotated around the horizontal axis, or the x-axis. Number 2, it says when finding a cross-section of a triangular prism, a trapezoid can be obtained by taking the cross section diagonal to the bases. So in this case, it actually works if I use this and then I draw it diagonal to the bases. So I'm doing this and then I have that side. So these two sides will be parallel and those two will be. So the answer is A here. If I take a cross section of a triangular prism that is parallel to the bases, it's actually going to be a triangle. Perpendicular to the bases is actually going to be a rectangle. And if I do from a vertex to an opposite side, it's going to also end up being a triangle. Number 3, it says which information is needed to show a parallelogram as a rhombus? Well, looking at my choices, it's always talking about diagonals, all 4 choices. So the first one says the diagonals bisect each other. Well, this proves that a quadrilateral is a parallelogram. So that does not prove that it's a rhombus. The second one, B, does prove, this is what proves that a quadrilateral is a rhombus. If they are perpendicular, if the diagonals are congruent, it proves that it's a rectangle. And then if they do both, that's a square. So your answer here should be B, which is rhombus. The next one, number 4, it says which of these could not be a fourth vertex of the parallelogram given the other vertices in the graph below. So the one thing that you need to know that the opposite sides of a parallelogram are parallel. Sorry, opposite sides are parallel. So I'm looking for them to have the same slope. So I'm going to start out by saying, okay, if I choose this line right here, and to find the slope of it, it's up to, and then it's to the left, 1, 2, 3. 1, 2, 3, 4. So up to and over 4. And this would be, so I would need to go up to and over 4. So that yields 0, 5. So that is a point. So I'm going to cross that one out. The next one is down here, 2, 7. So let's see what happens. So if I if I drew a line from there to there and drew a line from there to there, would those two lines be congruent or have the same slope, parallel? So 1, 2, 3, and down 1, 2, 3, 4. So from here, 1, 2, 3, and down 1, 2, 3, 4. So that one is a possibility. The next one is 8, 1, which is over here, right here. And so I need to see, does that create a line that's parallel to what I have? And it does create a line that's parallel to AC, because AC is down 2 and over 1, 2, 3, 4. And so this is down 2 and over 4. So 8, 1. The only one that's not an option here is 9, negative 1. So that would be your answer is D, 9, negative 1. Moving on along to number 5, it says write an equation of the perpendicular bisector of VW. So the first thing that I need to do is I need to plot the points, 2, 1, that's V, and then W is 10, 3. And then I want the perpendicular bisector. So bisector means that it hits it at the midpoint. So here, if I find the midpoint of VW, which is found by x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So 2 plus 10 is 12, divided by 2 is 6. And then 1 plus 3, so it would be 6, 2, divided by 2. So that would be my point that my perpendicular bisector is going to go through. And then I know it's going to be perpendicular. So it is going to have a slope that is the negative reciprocal of the slope VW. And my slope of VW is up 1 over 1, 2, 3, 4. So my slope of VW is 1/4. So the slope of the perpendicular line is going to be the reciprocal, so it would be just 4, and it's going to be the opposite sign. So I'm looking for a equation of a line in slope-intercept form that has the slope of -4. So automatically I can eliminate those two answers. I know that the line has to go through point 6, 2. So that's going to be my xy and when I'm figuring out what b is. So this is the equation of a line in slope-intercept form. I plug in my slope, I plug in my x, and I plug in my y, and I solve for b. So 2 is equal to -24 plus b. I add 24 to both sides. B is equal to 26. So at this point, I eliminated the answer A, and the answer is B, 26. Now this is one that might have a different answer, it'll have the same answer, but it might not be B, so make sure that that is the case. Number 6, it said T divides a segment AB into a ratio of 3 to 10. So to turn a ratio into a fraction, this is the formula, A over A plus B. So A is 3 and B is 10, so it's 3 over 3 plus 10, which is 3/13. So my answer is A. Number 7, it says find the coordinate of y that is 3/4 the distance from 3, 0 to -1, +8. So this is -1, +8, and that is z, and this is 3, 0. So I have this line, and it needs to be 3/4 of the distance this way. So it's going to be closer to z than it is to x. So I have the formula, and this is from your formula sheet, and it is x1 plus the fraction 3/4 times x2 minus x1. And then to find my y value, it's y1 plus the fraction 3/4, because it's 3/4 of the distance, y2 minus y1. And then we just plug in my x is my x1, y1, and my z is my x2, y2, because it starts at x and ends at z. So then I just plug in my numbers. I have 3 plus 3/4 and -1 minus 3. And then I have 0 plus 3/4 and then 8 minus 0. So 3 plus -12 over 3, and then 0 plus 24 over 4. And so here I have, let's just make sure I'm doing this correctly, 3 plus, this should be 4, -12 over 4. And so it would be 3 plus -3, and then 0 plus 6, and so it's 0, 6 is my answer. So moving on along to number 8. We have, it says, figure A is the cross-section parallel to the bases, so this is parallel, and this is perpendicular to the bases. So I have some options that if it's a square and it's parallel, it could be a square prism, it could be a cube, or it could be a square pyramid. But looking at it that it's perpendicular, any pyramid that goes through the point that's perpendicular to the base is going to have a triangle as its cross-section. If it was a square prism, it would have a rectangle as its cross-section. If it was a cube, it would have a square as its cross-section. So the only answer possible is a square pyramid. And the base labels what it is, names what it is. Which of the following equations describes a line parallel to the line given? So first thing I have to do is I have to figure out what the slope of the line is that's given. And so I just pick some points that actually intersect with an x and a y line. And this point is -3, 0, and that point is 0, 2. And I can see it's up 2 and over 3. So my slope is up 2 and over 3. And I know that also it's positive because it goes up. The line goes up. So the next thing I know is it's going to be parallel. So it's a line that's parallel, so it has the same slope. And that's all the information I have. So I'm looking for an equation over here in slope-intercept form that has a slope of 2/3. Well, this is slope-intercept form, but it has a slope of -3/2. So nope. Slope of 3/2, nope. This is not in slope-intercept form, so I need to put it in slope-intercept form. And by doing that, I'm just going to try to isolate y by itself. So 3y is equal to 2x minus 15, and then I divide by 3. So y is equal to 2/3 x minus 5. And so that actually has the same slope, so that's going to be my answer. And if I checked this one and I did all my math right, it would end up being y is equal to 3/2 x plus 8, which 3/2 is not 2/3, so that one's out of the question also. Number 10, it helps to know, and it will save you a little bit of time if you know the properties of a rhombus. And the properties of a rhombus are all sides are congruent. If you didn't know that property, though, you could still find the length of all of the sides. But by knowing that property, I only need the length of one side, and then I can multiply it by 4. So I'm going to find the length of GH, and I'm going to take 3 minus -3 and square it, plus 2 minus 4 squared. So the distance of GH is the square root of 6 squared plus -2 squared is the square root of 40. And so then when I multiply that by 4, square root of 40 times 4, I would actually get as my answer square root of 40 would be 6 something. So square root of 40 times 4. So my answer should be 25.30. Moving to the free response. The first one, it says a cylinder has a base, has a radius of 9 centimeters, and that base is a circle, and so it says find the area of the cross-section parallel to the bases. So the cross-section of that cylinder is going to actually be a circle, so the area of a circle is equal to pi r squared. So the area is equal to pi times 9 squared, so the area is equal to 81 pi. So that is a possible answer. Now you could have gone ahead and multiplied 81 times 3.14 and that would have been fine. The next one says calculate the perimeter and area, and the perimeter is the distance around this. So I need to actually find the length of all the sides. So I find the distance of AB, or the length of AB, and the distance of BC, and the distance of CA, and I add it together. And you can use the distance formula that you have, and you can see that it would be 4 minus 1 squared plus 1 minus 4 squared, and so that's 3 squared negative 3 squared, so that's the square root of 18. And then BC is going to be negative 3 minus 4 squared plus 1 minus 0 squared, or 0 minus 1 squared, sorry, 0 minus 1 squared. And so it's going to be 49 plus 1, which is square root of 50. And then the last one, AC, is going to be 1 minus negative 3 squared plus 4 minus 0 squared. So that's going to be the square root of 32. And when I add all of those up together, the square root of 18 plus, plus the square root of 50, and then plus the square root of 32, and that answer is going to be 16.97. Then to find the area, I'm actually going to make a rectangle that actually circumscribes the triangle, and then I'm going to subtract out the areas of the triangles that I'm going to kind of cut off. Then I'm left with just the area of ABC triangle. So the first thing I do is I find the area of the rectangle, and that area is going to be 4 times 1, 2, 3, 4, 5, 6, 7, so that's going to be 28. And then I find the area of each of the triangles. The area of this triangle is 1, 2, 3, 4 times 1, 2, 3, 4. So 4 times 4 is 16, divided by 2 is 8. Area of B, 1, 2, 3 times 3, so that would be 9, divided by 2 is 9 halves. And the area of C is going to be 7 times 1 divided by 2, so that's 7 halves. So the area here of ABC is going to be 28 minus 8 minus plus 9 halves plus 7 halves. And when I do that, it is going to equal 12. You can use your calculator. The next one, M, it says M is the midpoint of DF, so I'm going to go ahead and label M. And the midpoint would be I add the two x's together, 8 divided by 2 is 4. Add the two y's together and divide it by 2. And then N is the midpoint of DE. So N is the midpoint of DE. So add the two together, divide by 2. Add the two together, divide by 2. So 4, 5, and 6, 8 are my midpoints. And then from here, you find the length by using the distance formula. Okay? And I can use these points, or I can find half of the third side. It's, either way is fine. So I would have 6 minus 4 squared plus 8 minus 5 squared, which would equal 2 squared plus 3 squared. And that would be 4 plus 9, which would be the square root of 13. And to find the slope, what we would do is the change of y, 8 minus 5, over the change of x. And so it's going to be 3 halves. Moving on to 14, it says determine whether the parallelogram ABCD is a rhombus. You must show your work below, then write a statement to explain why or why not. Well, first, this is not a parallelogram, but that's okay, because we can just still check to see if it's a rhombus. So to check to see if it's a rhombus, I can see if the slopes are perpendicular. So here I can either say the slopes of the diagonals are perpendicular, and I can prove that by finding the slopes of the diagonals are perpendicular, or I could say that all 4 sides are congruent to each other, congruent. So I'm going to take the easy way, and I'm going to do the slopes. So I'm going to do the slope of AC, and that's negative 1 minus 11 over 11 minus 4. So the slope here is negative 12 over 7. Okay, so that's the slope of AC. And then I'm going to find the slope of BD. So if it's 7/12, it's going to be a rhombus. So I have 3 minus 7 over 4 minus 10 is equal to negative 4 over negative 6, and that's going to be positive 2/3. So no, the answer is no, because none of these are true. None of those are true. And I only have to prove one are true. Okay, so that should help you. Bonus you can ask your teacher about. Hopefully they've already told you. All right.